Nth roots and rational exponents is what we're talking about. So the two vocab words that you need to know: radical, which is anytime we use a square root sign or a cube root sign or a fourth root sign, that's a radical. And then rational exponents, anytime we talking about the word rational in math class, that means fraction most of the time. So we're talking about exponents that are fractions and radicals in this lesson. So down here we have a couple more vocab words. N is the index, A is the radicand. When basically what you need to know is when you have n equals 4, that means the fourth root. Radicand is what goes underneath the radicals. So the radicand is 16. So the fourth root of 16, or in other words, what number can you multiply by itself 4 times to get 16? And so we know 2 times 2 times 2 times 2 is 16. So the fourth root of 16 equals 2. But also, negative 2 times negative 2 times negative 2 times negative 2 is also 16. So the fourth root of 16 could be positive 2 or negative 2. So another example of that, we have n equals 3 this time. So this is the cube root of negative 216. Or in other words, what number can you multiply by itself 3 times to get negative 216? And that answer is negative 6. So the cube root of negative 216 would be negative 6. Oops. Oh my goodness sakes. Here we go. All right, so let's try a couple more examples of that. So we have the fourth root of 625, or what number can you multiply by itself 4 times to get 625? And that answer is 5 or negative 5. So anytime you have an even root right there, you could have 2 solutions. It could be positive or negative. Next, we have the sixth root of 64, which could be positive 2. If you multiply 2 by itself 6 times, or 2 to the 6th power is 64, or negative 2. The square root of negative 49, and you can put a 2 there, but if there's an invisible 2, or if there's no number there, it's an invisible 2. So square root of negative 49, or what number can you multiply by itself twice to get negative 49? Well, that's not possible with real numbers because 7 times 7 is positive 49, and negative 7 times negative 7 is also positive 49. So this one would have no real solutions. We know from a previous chapter that we would have 7i times 7i would work, but for today's lesson, we would just leave it at there's not a number. So even roots, you could have no solutions or 2 solutions. Let's skip down to these odd ones. So cube root of negative 125. So with odd roots, so when this number, the index, is odd, you will always have 1 solution. The number you can multiply by itself 3 times to get negative 125 is negative 5. All right, let's move on to rational exponents. So with rational exponents, again, that's exponents that are fractions. Some examples would be like 4 to the 1/2 power. That's the same thing as the square root of 4. You may not have known that before. Or 27 to the 1/3 power is the same thing as the cube root of 27. So here are some more examples of that. But now the top number isn't just 1. So 16 to the 1/2 power would be the square root of 16. But since we want 16 to the 3/2 power, that's the square root of 16 to the 3rd power. And you can put the 2 there, but if there's no number there, again, there's an invisible 2. It's just a square root sign. And when you rewrite it like this, now we can actually solve this. So the square root of 16 is 4. We're just going to take the positive answer. So 4, and then to the 3rd power. 4 to the 3rd power is 64. So 16 to the 3/2 power is 64. You do need to know how to do this without a calculator. So next example, we have this 4 to the 5/2 power. So again, the base is 4, so that's your radicand. That's what goes underneath the radical. There's a 2 there, or you can just leave it blank, an invisible 2. And we're going to raise it to the 5th power. So the square root of 4 is 2. 2 to the 5th power is 32. This last example is a little bit trickier for a couple of reasons. First, it's negative. And from, again, a previous chapter, we learned that anything to the negative power, so if I had 6 to the negative 1 power, that's the same thing as 1 over 6 to the positive 1 power. Or 6 to the negative 3 is 1 over 6 to the 3rd. Same thing here. We have 32 to a negative power, so that's the same thing. Let me rewrite it here in a different color as 1 over 32 to the positive 3/5 power. But then we're going to take what's underneath there and we're going to rewrite that as a radical instead of as a rational exponent. So we have the denominator, that's your index. So our index is 5, the 5th root of 32. The 5th root of 32. And then we're going to be raising that to the, oh my goodness, I don't know what's happening, to the 3rd power. All right, so the 5th root of 32 is 2. 2 to the 3rd power is 8. So that answer would be 1/8. All right, so here's some more examples. I'll go through these a little bit quicker, but some more examples along the same way. So this would be the cube root of 8 squared, or 2 squared, which is 4. This would be the square root of 10. So you can put a 2 there and a 1 there, but it's just the square root of 10. This one is negative, so it would be the cube root of 24 to the 1st power, or to the 1st power, we can just leave that alone because there's an invisible 1 there. And then just make sure that's in the denominator since it was a negative exponent. And then the last one would be the 6th root of 32 to the 5th power. So denominator is your index, the base is your radicand, and then the numerator would be your exponent. So going the other way, this one we have the cube root of 8, and this is an invisible 1st power, so that's 8 to the 1/3. On this next one, our base would be 5, and then our exponent would be to the 5/4 power. And then remember there's an invisible 2 here, so this would be 10 to the 3/2 power. And then this one, we have 3k as our base. Our exponent is negative because it's in the denominator. There's an invisible 2 there, so that's negative 5/2. These examples are more or less the same. One thing to note is sometimes we're going to be solving these, and so when we're solving these and it doesn't come out evenly, so like a lot of these come out evenly, like this one would be 1 over 9 to the 1/2 power, or 1 over the square root of 9, or 1/3. That one comes out nicely. So does this one, 81 to the 3/4 power would be the 4th root of 81, or 3 cubed, which is 27. But 9 to the 1/5 power is the 5th root of 9 to the 1st power. And that doesn't come out evenly. So when it doesn't come out evenly, you will need to type that into your calculator to get a decimal answer when we're actually solving these and not just rewriting them. So make sure, practice writing it in your calculator. If you're going to type it in like this, you would do 9 to the 1 divided by 5 power on your calculator. There's also a way to do it with the radical. You just have to look for that special radicand button. But like if we're looking over here, I think it's easier to type this into your calculator because there's no 4th root of 7. So you would need to use your calculator on this. It's easier to type it in as 7 to the 3/4 power than to try to type it in as a radical. So just a little tip there. Okay, the last thing we're going to talk about is solving equations with nth roots. And your goal when solving equations, of course, is to get the variable by itself. So our goal is to get x by itself. And so anything you can get rid of, get rid of. So in this case, we can divide by 4 right away. So that's going to be our first step. So then we have x to the fifth equals 32. Then we need to get rid of that fifth power. Well, to get rid of a fifth power, we are going to take the fifth root of both sides. Because what happens is the fifth power cancels out with the fifth root, and we're just left with x. So x equals the fifth root of 32, or what number can you multiply by itself 5 times to get 32? And that answer is 2. So our answer is x equals 2. On this next example, we cannot add 3 to both sides first because that minus 3 is trapped in the parentheses. So our first step on this one is actually going to be to take the fourth root of both sides. So this is tricky for 2 different reasons. The first reason this problem is a little bit trickier is you have an even root. And if you're taking an even root, you get 2 answers. Just like in the quadratics chapter, every time we took the square root of a number, you had to add the plus or minus sign because you got 2 answers. Same thing here. When you're taking an even root, you get 2 answers. So the second thing that makes this problem a little extra tricky is the fourth root of 21 doesn't come out evenly. So you're actually going to have to use your calculator to do that. So the fourth root of 21 is about 2.14. But it could be positive or negative. So then our last step, we're going to add 3 to both sides. So we have x equals 3 plus 2.14 and x equals 3 minus 2.14. So your 2 final answers would be 5.14 and 0.86. There are a couple more examples on the notes you can use to help you out with this lesson. Reach out with any questions.